Hey everybody, welcome to episode 4 of Show Me SaaS. Joined here by the usual cast you maybe are getting used to see. I got Michael here with us today. Michael, you want to say hi? There you go. Toby, put your hand
Hi.
up. Nobody knows who you are. Hopefully from our prior videos, you've got a sense of who's here. So we won't spend a lot of time talking about who we are and really instead turn our attention to the topic we have today. And honestly, this topic of designing sort of multi-tenant microservices is one that we've seen people pretty interested in, and because I think it is an area that lots of SaaS developers are thinking about, which is, tell me not just how to build a microservice-based system, but tell me what it means to build a microservice-based solution in the context of a SaaS environment. And so that is going to be the focus of our show today, which is we're going to just look at, so as we usually do, like some of the big concepts around like SaaS and microservices, and then we'll actually dig into the like actual underlying implementation of some of these microservices to show you how a microservice looks a little bit different, actually sometimes quite a bit different in a multi-tenant world, and what we do to try to make it so that that multi-tenancy isn't in the way. It isn't somehow making building your system harder or making it more challenging and more difficult. And so the whole takeaway here might be, are these techniques or strategies that as you're thinking about getting into the weeds of building your microservices for multi-tenancy, that you'll have at least some of the ideas and some of the best practices to sort of weave into whatever it is you're doing today. I know maybe the best place to start this discussion is maybe at an outer level here a little bit. Instead of just getting right into the code, though, I think it's important to note that, to me at least, and I've done talks on this and so on, like what it means to build a microservice in a SaaS environment. Like, which microservices should I choose? Which ones are the right ones? What factors might influence which microservices I have is often a big part of that process. So maybe Michael, I'll just put you on the spot here for a second. Like when you think and you talk to people about building microservices in a multi-tenant environment, like are there things that you point out or things that are like top of mind for you?
Sure. I think it's a couple of things. Sort of what are the big moving pieces that you need to think about? So things like identity, right? Because if you don't have identity, you can't sort of make decisions about the rest of your software, and logging and metrics and some of those sorts of ideas where you want to have tenant context. But I think also what we like to talk about is what should the developer experience be when you're developing these, when you're writing the code for these microservices. And we talk a lot about how to sort of cushion the day-to-day work and activity of a given developer by trying to use shared constructs, shared libraries, things that they can leverage that give the microservice multi-tenant capabilities without having to reinvent the wheel or invent a different wheel for each service, I think, which is often what happens.
Yeah, I guess for me, there's even, and I agree with everything you said. And I think that as we get to the back half of this talk, we'll absolutely, that we're going to see some of that stuff sort of play out. But I also think there's just like is this a valid microservice? Like what are the because we'll see lots of people talk about domain driven design, and they'll see all these different techniques to try to figure out like which objects in their environment or which domain concepts should map to which microservices. And for me, that there is a layer of thinking here that is like, well, what's the noisy neighbor sort of things you're thinking about? What's the tiering strategy? So which microservices you even end up with could be different in a multi-tenant environment. So if you think like Toby, if you were sitting down and like thinking about and helping somebody sort of figure out like which are just the right microservices in their system, are there things you would look at to say, this functionality clearly needs to be its own microservice, or no, this can be pooled, or like how coarse grained or fine grained it might be based on SaaS considerations?
So is the question how to kind of divide up the responsibility of a microservice, or
Yeah, so think of service decomposition. So here, I'll throw something on the screen here, right? Imagine in an environment that I have all these tenants of all these different loads and profiles consuming my system in all kinds of different patterns that I don't expect. And I offer them even different experiences, different tiers, different SLAs, so on. And then I have new ones always coming in for onboarding and joining this sort of experience all the time. And now somewhere in here, I have to decide what's the right footprint of microservices here. Is there a case where tenant one gets their own microservice because of some of the microservices are dedicated and running in a silo model for tenant one because they're in some premium tier, and I want to be able to give them a different experience. I guess this is the sort of realm I'm looking at. Are there
well, that's different though.
Go after?
That's different than define. Like, I feel like if the question at hand is that how do we know what should go into a product service versus the order service versus, as an example, right, versus splitting those services up based on some kind of deployment profile or something like that, right? Two distinct things. If the first thing, I don't know, from a like a software design thing, I think microservices try to be as single use as possible, right? Like as scoped and use as possible, that you don't want it to be like some God object that's the center of everything. It's kind of the idea behind them is that they provide this like mesh of functionality that is, you can weave together in interesting ways. That would be my take on it. That's a very squishy answer.
Well, I think what we're trying to get at is, let's say you do that, right? And you break down your business domain and you come up with your nouns in your system, and you come up with the major business actions that are going to happen: shopping cart, checkout, product catalog, yep, reviews and ratings or whatever, right? Obviously this is all e-commerce made up stuff. And you do that, but then you put that into these multi-tenant environments, you might find that the natural, normal, quote unquote, delineation and split up of these microservices might not work in the multi-tenant world because of some of the things that multi-tenancy puts on top of the system, like noisy neighbors, like I think batching is a good example, right? Todd, I think you've talked about that before, right? So if you've got something like, say you've got a service that runs reports for people, or maybe, or back to the e-commerce idea, maybe you've got a service that ingests catalog entries. And you're multi-tenant, so you've got lots of different customers and they each have their own product catalog. And there's some process that happens either throughout the day or in a batch where they update their catalog that they're selling to their customers through your SaaS platform. And it could be that tenant A, that the way that they interact with that update catalog service is completely different than tenants, B through D or whatever. And then therefore, do you need to change how your microservices are delineated because of multi-tenancy that you wouldn't have had to do otherwise?
Yeah. And I actually contend, and that's absolutely in the spirit of what I'm after here, which is, I feel like if I just do the classic sort of thing to say, go domain-driven design, just decompose my system of microservices. Yes, they're smaller, they're more autonomous, they deploy, they get all those good things that have less of a blast radius. That's all really good. And I get all kinds of agility out of that. But in a multi-tenant world, I can't stop there. I have to ask another layer of questions on top of that, which is, hey, I could end up, because we could be potentially sharing infrastructure across all these tenants. And I may be wanting to offer one tier of tenant a different experience than another. And the only way I might be able to achieve that is by taking, hey, this really high value area of the system that has a really high SLA need can't afford to have a noisy neighbor problem. And so I'm going to put my basic tier tenants in some pooled microservice for that. And then I'm going to deploy a separate set of microservices for this noisy neighbor area to give a different experience to somebody. The same thing could be true of isolation. stories, right? Like some
Sure, I
high
think-
value customers. Go ahead.
Yeah, I feel like the isolation bit is probably more well, two distinct things, right? You could handle some of the noisy neighbor things by not only deploying a separate set of services, but maybe depending on your compute stack, upping the container, and that term used generically, not to mean a real container, but upping the container that the compute that those services run in versus putting them, say, in an isolated way that's more about the isolation aspects of it versus making sure that you've got the appropriate level of compute to support that noisy neighbor or whatever.
Right. And I want this to be I'd say that this is my own bias, but across microservices in general, I would not like to think of all microservices as just being like representations of domain objects. I always want to overlay what's the actual operational and the sort of consumption use cases for these things, because something that might in the domain be logically one microservice might break down more naturally into two if I were in another environment. So when I look at isolation, noisy neighbor, and I look at tiering, which is just, hey, I want to offer a different experience to somebody. Like maybe somebody just won't buy the system unless some piece of it is guaranteed to be isolated, even though it doesn't have noisy neighbor problems, for example. That may just be a lever you have in terms of packaging and offering something to somebody who says, I sort of demand that experience.
Well, I think we always say that a microservice should sort of earn its way out, if you will, right? That start a little more coarse grain, start with fewer services, gather metrics so that you're making objective decisions, and like you say, that might give you insight into where you might normally draw the line is not actually the right place to draw the line, given the load that's being placed on the system. Or like Toby said, you can find that if you vertically scale your compute or your disk IOPS or whatever, you may be able to solve a problem that you weren't even aware of, as long as you've got those metrics.
That's a good point.
I think in non-multi-tenant environments or classic environments where your load is way more predictable, like generally how customers are consuming your environment because it's typically a customer consuming your system and they have patterns for how they're consuming it, and their loads are more predictable. This is an easier discussion to me in a multi-tenant environment where you're saying, like, I really don't know how people are going to do this, but I know I have certain tiers in my certain system and certain experiences. And if I have to sort of create these boundaries of experience because I don't know how people are going to consume it. And I don't want some basic tier tenant undermining the experience of my platinum tier tenant. So I have to think of new strategies and new ways.
Well, and you might not know how your business is going to grow, right? Yeah. Especially if it's a consumable service with a fairly low friction onboarding experience. Going back to our last discussion, where the tenant can drive the registration process themselves. You may have designed your system to work great, and you test it up to like 500 tenants, and all of a sudden, you go viral or whatever the phrase is these days, and now you've got 750 tenants and things aren't working anymore, or you need to split up your services in a different way for that many tenants versus your lower number.
Yeah, I had a sort of, you guys didn't see this, but I had a bit of a convoluted example of this, but I tried to highlight the idea that imagine I have this product manager service, and I look at the distribution of load across that service and find out that one tier tenant is consuming in one way and another tier tenant is consuming it in another way. That might be motive for me to say, hey, my platinum tier tenant is saturating the update inventory experience and they're not getting as good of experience out of it. And would that lead me to potentially say, hey, I could actually break, maybe right now product manager had inventory all inside of it, and now I could break inventory out and say, hey, inventory's got so much consumption on its own. And there's all kinds of questions you could ask behind this use case, but the sentiment here was, hey, once I've got this thing up and running and I see this I can start to profile this activity. I can reassess whether these are the right microservices. But this also relies on you having sort of good metrics and analytics and insight and how different tiers of tenants and different tenants are consuming your microservices.
That's
well,
yeah.
I was going to say,
you're probably going to say the same thing.
Well, we've got a question. We've got a question that speaks to that, right? And I think the easy answer is to say yes, of course, metrics-based scaling can be the solution, but I think people underestimate how difficult it is to gather the right metrics. And sometimes you have to change technology, right? Sometimes you'll have to change underlying choices about how you set up your system, whether that's maybe database technology or compute technology, or the way that your microservices communicate with one another. How asynchronous is it? How directed are those messages? So yes, you do have to scale and understand what your tenants are doing to your system.
I think the real question that's in this one is, well, we have horizontal scaling, and can't we just scale a bunch more microservices of that microservice, and therefore we don't have to worry about like noisy neighbor because it's scaled out enough to do it. But in a multi-tenant environment, like just counting entirely on horizontal scale as a way of getting around noisy neighbor doesn't always cut it. Like I could have things that are not really driving scale, but are suddenly super compute intensive, like an analytics request or something that's that nature, where I could eventually scale wide based on that, but I may not be able to scale wide fast enough to meet the needs of that. I could still end up with noisy neighbor, even with horizontal scale, I guess is my point.
Or to your point earlier, Todd, where you have, let's say you've got a service that is wearing a couple different hats to start with, right? And maybe it's one aspect or one thread of that service that is being completely pegged, but the other, the other stuff that service is handling is maybe less so, right? If you don't have the right metrics to kind of identify kind of a layer deeper, right? Not just the service as it acts as a whole, but what's going on inside of it. That's another issue.
Yeah. These are great questions. Keep them coming.
Yeah. Isolation is the one that is to me, like the most prevalent one here, right? Like noisy neighbor, it's a complicated discussion. Some things can be achieved with horizontal scale with noisy neighbors. Some things can't. Some things the SLA still won't necessarily be what you need it to be, depending on the nature of the operation. But the other motive here is often an isolation one, which is a customer will just say, this realm of data for me, for a platinum tier tenant needs to be, or this realm of functionality needs to be isolated from other tenants. And I want to buy your system and be assured of that. And that's where that will affect my sort of microservice decomposition strategy.
Well, and you also have to think about some designs sort of pin the tenants to given infrastructure, especially because we've got these cool tools where we can horizontally scale stuff underneath. But so it's like if you start thinking about how you're sharding your tenants across, right? So maybe you realize that you need more than one database to support your tenant load. So you've got a few different database instances or clusters, and then how do you pin a tenant to a given cluster to prevent some of this noisy neighbor and scale problems? Or how do you move somebody out who you've identified and move them to a different chunk?
Yeah.
Cool. So that's clearly a topic we could go much deeper on and talk about all the use cases here. But I want to pivot a little bit here to, okay, so I've picked my microservices and whatever of these factors that we used, noisy neighbor or whatever, I've got a microservice. I've got to build it. And if I were to say to you, hey, go look at somebody else's solution that's a good multi-tenant microservice solution, and you cracked it open and looked inside of it, what are some of the sort of attributes or traits you'd be looking for that it would show to you that, hey, this is like this system, this microservice is being built in a way that conforms to good practices. It makes it's not like you were talking about, Michael. It's sort of cushioning the experience for developers, right? And that developer experience is a big part of this whole thread I'm talking about here, which is just like when I look in there, does it look like it's like multi-tenancies, like affecting everything and touching everything in the building out the functionality of my system, or is it gracefully introduced somewhere, or like what do you look for?
Yeah, I think from sort of a macro level, I think you look at sort of how many hops, if you will, like how many different pieces are required to come up with an answer. I think we talked about this a little bit during onboarding, and we were showing some examples sort of, you know, I think you expect to see some sort of tenant identity in your microservice, right? So when you open up that microservice code, somehow the code has to understand the context of the request that's coming in from a given user. That user belongs to some tenant, and you have to understand that relationship between the identity that's authed into your system and the tenant they belong to, so that you can make all your other decisions. And so the question becomes, how sort of smooth can you make that understanding, that connection between that identity and that tenant? And did you have to go talk to another service, go send a request response across the network? You know, how sort of contained can you make it while not building a monolith and making fragile code?
How about you, Toby? I mean, if you were doing a code inspection on a microservice, right? Like, are there, and you knew it was multi-tenant, like, are there things, maybe I'll ask the question the other way. Are there things you'd look at that you would be like big sort of red flags, that maybe things are, that aren't broken, but they are less, they're more cumbersome maybe than they should be?
I mean, I think in general, you know, the same things to good software engineering apply in microservices as well as everywhere else. But the ability, you know, having kind of, we kind of kicked this whole conversation off with this, having the ability to kind of pull out all of that boilerplate stuff that handles multi-tenancy into something, right? Whether that's a shared library, a sidecar, or something that isn't, so you're not repeating yourself all through your code where you're cracking open the same token and you're doing the same old stuff, right? Being able to kind of have that pulled out in a way that takes as much of that stuff off of the developer's plate as possible is a good thing. And then also just trying to create some bumpers, right, for the developers so that they don't, so they can stay out of trouble, right? Like you don't want to recreate all of those problems everywhere if you could do it one place, and then if the problem comes up, you fix it in one place, right? Typical software engineering stuff.
Yeah, I look at this sort of problem through two different lenses. I look at maybe how clean the code is in terms of like how much is the multi-tenant sort of, oh, I've got to look up isolation, I got to figure out your tenant context, I got to figure out all these things to like apply tenant context, and how much is that disturbing the flow of what this function is trying to achieve, which is something that is just, I need to perform some operation. Like how much is it clouding that? And then I also think is, I have policies that I'm implementing for my microservices. I have an isolation policy that is like got to be enforced somewhere in the invocation of that microservice. I would like those policies to be outside the view of the developer, right? I'd like to be able to say, we decided this isn't a policy. And yes, maybe at some point as a developer, you opt into that policy as best you can, but mostly something like isolation just works. Or if I've got data partitioning and I've got like, hey, depending on your tier, it's pooled and you're sharing a table for all tenants, or it's table per tenant for DynamoDB because I'm this tenant's a platinum tier tenant is separated. I would love that in my code, the code that says go insert or get an item out of that data is hidden for me. And I think, Toby, you're right in that is just classic good. Even if we weren't multi-tenant, we'd say put a library or something between us and there to hide that. I would just say this adds like that multi-tenant context gets baked into that same experience.
Totally.
Mm-hmm.
Cool. Now, I'm Michael. I know I just want to make sure we were having technical difficulties earlier. Is your screen share? I don't see it here.
I turned it off because it was killing my laptop here. Toby, I shot you.
Yep.
Some
I
of
got
those
it.
files. I don't know if you could attempt to open those up.
Yeah, let's I don't have Python installed in this box, so there might be some syntax issues, but
we're going to do this on
I do
the
have
fly.
Python,
Why
but I don't
not?
have it in VS
Right.
Code. All right,
we've got some code, but the screen
do it
share,
live.
I know for Michael, was having some issues.
Hold on 1 second.
What we're really trying to do here is we've got some code behind that, that sort of shows this evolution that we talked about, right? Which is, okay, we were saying that you want these certain attributes in your code and things you're looking for. Like, what would that actually look like if we were to poke into some code here? And what would it look like for maybe if something that's a little more crowded with multi-tenant code that shouldn't be? And what would a pared down version of that look like, knowing that the solutions to this are sort of all over the map? Depending on which technology you're using, which stack. Yes, Toby.
So I have it, but I have a Chrome update that that wants to close my browser. So we're kind of stuck. I should have done this before we went live.
No, it's my fault. I will attempt, and it may not go well, but we'll give it a shot.
If you start getting all pixely and the robot sounding, we'll know something went wrong.
Yeah, right. If it fails, Michael, we'll drop you from the stream and we'll just walk through the other example we have of this. But I was kind of hoping to show the bits you had here.
Okay, well, I'll do this. I'll try to remove my camera and then try and turn on the screen and see what happens.
Hey, see what happens now. I would say it's struggling. All right, I'm gonna go ahead and pivot to the other one, Toby. I don't know if we may have even lost Michael. Michael, are you still there? Okay, I'll pivot to the other example.
Okay.
So Michael had an example where he sort of had a progression here, and we do have a workshop that we built. That is built around this notion of Lambda layers, but it still has this whole notion of like, what does it mean to build a really good microservice in it? And in this particular case, what it's saying is, I'm going to take all these horizontal concepts, all of these bits that we would normally share. Sorry, going to pivot over to this screen. That we would normally share, like logging and metrics and analytics, and it's pushing them all into a Lambda layer. And for those of you who haven't done serverless, Lambda layers are essentially a way to say, go to package common concepts into a layer and then bring them all into your other Lambda functions as a shared concept. And then they're deployed and managed independently. And if you're in a serverless world, this is really awesome because I can essentially update and deploy these shared concepts independent of the individual microservices that consume them, and then they'll all just sort of get updated across that. But really, even if you're not using Lambda layers, the concepts are the same here. So if you go look at what we've done out there, we've said, what are the pieces of code? What are the common things that would come into a microservice that would need to be processed contextually by each individual microservice? And obviously, one of the ones you'll see across almost all of our content is this notion of a token manager, right? And this token manager is really meant to say, hey, we've got this tenant context. It came into us as a JOT token, and we need to be able to extract tenant, tier, all those bits out. Well, we don't want to have that like in every microservice where the breaking of the token and potentially dealing with the signing of the token and figuring out like where in the header it is, all strewn across all of our microservices as like copied code all over the place. So instead, we make these really simple helpers. So there's no magic here. It's just a simple little helper function. But all these lines that are here to deal with the token now are reused everywhere we need tenant context. And so it makes this a much cleaner experience. And in some cases, this can be a lot more code depending on how you're dealing with unpacking the token. And there are other things that can be going on here. But the nice part is now, when you'll see when we get back to a function, every time I need a tenant ID, I essentially call this helper. The helper gets me the tenant context.
And Todd, you've got examples of where we're actually using this layer somewhere?
Yeah, so I'm gonna pop back to at the end to show how these helpers get brought in and change kind of the feel of a function, cool. Right? So I have that, and then this is really something super simple, logging, right? We all have to do logging, and you'd say, well, logging's not a big pain point for my now Michael is now sharing. let's not do that. Let's go back here. Michael is now sharing. I'm sorry, repeated myself. Comedy of errors here. Logging is here, and now our logging experience. Toby's laughing at me because he knows we're struggling through this moment. And you'd say, well, I just have log. I have log statements inside my code. Why do I need to do any sort of helper for logging? But the truth is, when we log, we often want to embed lots of tenant context into our logs. We want to put the tenant ID in there. We want to put the tier that you might be in. We might pack all kinds of contextual data in there that on the operational side is essential to sort of sifting through this. So if I have a problem and I want to say a tenant or a particular tier is having issues, when whatever tool I'm using to work through the logging, all that data and all that metadata will be in there and let me filter and view this in the context of tenants. And I won't show you all of these, but essentially you'll see I've got a metrics manager. This is another concept here that is, we separate, like we talk a lot about the need to record metrics and analytics for your microservices, like, hey, what's the latency of this function, or what's a feature they're accessing, what all this data we want you to collect to run really good metrics and analytics about just what they're consuming, why, and get all that data. That also needs all that tenant context in it. And you'll see, by the way, all of these helpers are using the other helper, which is this token manager, to get the tenant ID on. So they kind of build on top of one another. And in this example, it does get a little richer. You'll see, for example, we have this notion of a partition manager, and this partition manager is actually responsible for, hey, what's my data partitioning scheme? And do I need to create a table? Do I not need to create a table? How do I map you to, are you siloed? Are you pooled? That whole discussion I was having earlier, that all gets pushed into the helper. And so now when I go look at the actual code here, you'll see, and this is you're seeing it in the context of this workshop, because this code is actually, you're asked to insert this code as part of the workshop. You'll see at the top of my code, you'll see that I'm pulling in this token manager. I'm pulling in these bits from the layer that I have my dependency on. And now the key here is this big payoff is when I look at this update order function, you'll see that this update order function now is a much cleaner function, even though it has all kinds of tenant context all over it, right? So when I say log here and I tell it to log, I just tell it to log and I share the context with the log, and somehow all the goodness of tenant context gets injected here. You'll see here, I need the tenant ID. I just call this, and this is back to a point Michael was about to make, which is I see lots of people as a resolution to this creating other microservices to support these horizontal concepts. So I'll see a tenant manager and I'll see people in their microservices calling another microservice to resolve the tenant context. And then the natural problem we end up with here is these other microservices, because we are calling these things over and over again, like each microservice we're calling them. Now this tenant manager suddenly becomes this huge bottleneck of the system, and I have to try to figure out how to scale it. So part of the goal here is to make it, like Michael said, make it so that we're not having to, if we need this key data for multi-tenancy, we don't want to leave and go call another microservice to get it. We want it to flow through this experience. So by the way, Toby and Michael, like, feel free to stop me here. I'm kind of trying to catch up from our little there.
I was going to ask the question that you already addressed, which was, so these guys, these layers are deployed separately, but from a Lambda perspective, they're in process. It looks like all I'm doing is just doing a regular node require just to pull it in, and it gets mounted almost as a file or something on the Lambda function. I don't know much about this.
Yeah,
I mean, wheelhouse.
Lambda takes care of like deploying and putting these out there as libraries, essentially shared libraries, and then a given function can reference a layer and then import things from that layer. And so now it becomes, it really, and this is why it's a cool construct in Lambda, but it's not wildly different than saying I created some kind of reusable jar or some kind of reusable library in another language, right? And
and this is a little bit off topic maybe. What's the upper limit here? Can we can't have an unlimited amount of these, right? It's like,
well, now you're going to ask me a limits question as if I have that memorized off the top of my head. There, I don't
think
know.
You can only have
I don't know what the limits are there.
5?
But,
okay.
There certainly are limits, and there's certainly, you don't want to go crazy with just throwing everything into layers here, right? You should still be using libraries the way you'd normally use libraries. To me, the thing here that's nice is that these are deployed, like they have their own pipeline to some degree, right? Like you could say, and they are versioned independently. And to me, I like that dimension of it, because now I sort of can imagine I have all these isolation policies and all these other things that are baked into these common libraries. Now they get deployed. And if I want to update something about a policy, it can update it. Everybody gets it. And I don't have to redeploy the microservices.
Totally. No, that's awesome.
Yeah. So here you'll see this token manager gets a tenant ID, and then we have this thing to call this partition manager that's also in the library, that lets us go out and essentially determine, hey, what is your table? Like, I need to resolve you to a table, but I don't know whether you're siloed or pooled, and I don't really care in my function as a developer whether you're siloed or pooled at this point. Because I'm going to operate on this table left and right. And yes, technically under the hood, I probably somewhere do know what the policy is for silo or pooled, but in the writing of all these functions, this is just one. There's 8 functions across this microservice. They all just call this partition manager, and the code in the actual microservice itself isn't somehow now convoluted with all that logic around how to deal with it. And yes, it'd be a helper in here, so it would be a little better, but it's still nice to have that policy kind of pushed out there. And then you'll see here, we actually record a metric, and we look how long it took to run this, and we record how long this update order took as a metric, and that gets sent off to our metrics. So whatever's behind our metrics in terms of, is that going off to Elk, or is it going off to some other Redshift or something else that's aggregating it? That's all sort of outside of your view. So to me, when I look at this function, and this is going back to that discussion I had earlier, what I like here is, if I didn't know this was a multi-tenant environment, how much of what's here sort of is relevant to the multi-tenant discussion? I think most of the functionality that's here has very little to do with multi-tenant. This could be a classic system with no multi-tenancy at all, and most of this code would still be the same, I would think.
Yeah, I think that's cool. I have an example that we did in the other workshop. If I could send it to you if you want to bring it up on screen. I can't.
Or no, just do a share on your side if you can get it to work.
I can't share.
Oh, you can't share.
Yeah,
well, that's not
Chrome's busted. Do you want me to send it to you?
How are you going to send it?
I'll just private chat you here.
Let me see if I can pull that up for you.
So there's that guy.
Let me just grab this. Let's see if we can open another tab here.
Having some Chrome issues today with this.
Okay, Toby, here's one.
Okay, cool. So is that big enough?
You want me to zoom it in?
Yeah. So the key point here is that this is a node stack, right? So this is a little bit different than, well, it was kind of the same thing, but it's not using, this is node running at least in this workshop, it's running on EKS. So the one point I wanted to make here is that if you notice on this, on line 17 there, that create, how we're just injecting tenant credentials. This is kind of another one of another form of this shared library, right? It's not necessarily a Lambda layer. It's not anything like that, but this is a decorator that effectively, if you were to call this thing, all you'd provide it is the body, right? The DTO. So
Right.
from a rest perspective, this thing gets called with a DTO. That other bit that's on the end there gets injected by this framework that we're using. And so if you look at that second link,
I'll go get there. Hang on, I'm going to get that for you right now.
So this is where that all kind of gets injected here. So we've got a jot that knows how to kind of crack it open, knows how to pull the stuff out of it. And then that validate method there on line 30, on line 31, we're returning what is effectively the user that ends up as that tenant credential injected into each of these methods. So we handle all this in one place. This is a shared library that is used across all of our backend services. And it just gets injected by way of that tenant credential. And now, where we're in our method, like if you go back to that controller, actually, let me go to the service that's actually using this. 1 second. So if you go back to the controller, notice that it's doing an order service.create, and it's passing the DTO, but it's also passing the tenant ID of that injected object.
Where are you referencing that?
Line 18.
Well, and I think the next level of this is some stuff that we've also done before, which is so clearly the order service is going to instantiate an AWS SDK client to talk to Dynamo or Redshift or an RDS data. Somehow it's going to create an SDK client, and then you can start talking about isolation, where now you can create that SDK client within the scope of a set of IAM credentials that are only applicable to that tenant. And so the next level would be to essentially make like a factory, kind of like we have here, a factory, design or a factory pattern where you're vended as the developer that it's writing this code. You're not instantiating the SDK client. You're asking a shared construct to say, hey, get me a DynamoDB client. And here's the request that I'm acting under the context of, and the DynamoDB client that comes back to you has been scoped down with IAM credentials that apply just to this request.
You're teeing me up for another part of this thing. If we wanted to look there, Todd, I put.
You want me to drop this in? Yeah, because to me, the bit that we've sort of went for the low hanging fruit version of this so far, which is logs, metrics, tenant context, are all awesome. But where one of the most common sort of use cases here is isolation, right? Which is how do I actually go resolve this tenant to the set of IAM policies that are going to scope their access? And that to me is an area that if I'm building microservices for multi-tenancy, like everywhere my code is touching a resource, I want to be able to know that there's some kind of isolation policy attached to it that says, am I crossing the boundary to another tenant? I don't want to rely on authentication or authorization as the only thing that says, well, you got to the function and developers write well-behaved code, so we're pretty sure you're not going to cross a tenant boundary. I believe all those things are true, but no matter what, in a multi-tenant environment, we still want isolation policies that say if something happens to go wrong and somebody does try to cross a boundary to something they're trying to get to, they shouldn't be trying to get to, maybe another tenant's data, then we want something to block that path. And this is another place where we introduce that concept as a shared concept and a library inside of the code. Now, I don't know if that's where this code is going, Toby.
So if you look at this guy, this is just the service that was being invoked by the controller, right? So this is typical.
This is the order service, and this is that create function that you were talking about.
Yep. And if you look, this again is part of a workshop. So one of the things that you do through this workshop is take this code and modify it to make sure that we've added all of those policies that you just described, and make sure that a tenant can't that we're surrounding it with another layer that ensures that we're putting a policy around the actual data access as that service reaches down into Dynamo to make sure that we're only getting the stuff that tenant can see. So to start with, this can hit a Dynamo table and it could just pull back everything, and then eventually we'll add some context to it. But if you notice there on line 32, we're doing a fetch client, and that's a method down at the very bottom of this file. That is just essentially returning a DynamoDB client with no context. And then eventually you'll see we've got some, but to Michael's point, we're injecting a client factory service in there. That's not really used at this point in the workshop, but eventually that factory service is where all the magic happens, right? That's the thing that knows how to take the tenant ID and do all the cool stuff with dynamic policies and all that stuff.
So, but if we kind of go out, because maybe I think we probably hopped into this pretty fast, and sorry for those of you that are maybe if this is a little hard to follow and we're jumping around a little bit here, but the spirit of this was, hey, I showed you Lambda layers and the way that Lambda layers could pull in these common libraries around these common sort of concerns. And then here we have a different language construct, which is this injectable sort of construct, right? Which is saying we're still doing the same sort of thing. We're achieving the same thing, but now we're doing it through this language construct or this library construct that is lets me make it clean by declaring it through this injectable sort of syntax. Is that kind of fair?
Yeah. I mean, a key point being that in both cases, either layers or this, decorator that gets injected, it's something that you've taken, again, this is typical software engineering, but you've taken all of those moving pieces and you've collated them into one place, so that, you've got one bug to fix if you find some catastrophic error in there, or, it's just dry, right? It's a typical dry principle.
Yeah. In fact, I would encourage people, and maybe we'll find a link and drop it out here. We have this library that's called the dynamic policy generator. I think I'm trying to remember it. And it's one of our more commonly used tools. And that tool essentially is a library to help make it easier for you to sort of runtime declare policies and then connect it to your microservices here in a way that the microservice just inherently uses that library to resolve the policies, get back the credentials, and all that heavy lifting happens outside of your view, so that now you can just use those credentials and you have sort of tenant scoped access to resources. So it's a great example of something that would sit in the heart of an experience like this. So maybe I'll take the code away here, and I'll pivot to a slightly broader question here, which is like, libraries are one way to solve this problem. And certainly reusable libraries are the natural thing that developers think about. But when you're writing a multi-tenant microservice, there are other opportunities and other sort of ways, depending on the stack you're in and the technologies you're using, to say implement isolation or to implement a logging sort of special logging handling. I know, Michael, this is a topic you've talked about before in other contexts. Like, how would you sort of categorize maybe some of the different ways that people could implement these common constructs?
Yeah, no, it's true. In fact, we had a talk at reInvent this year that touched on a lot of this. Unfortunately, it wasn't recorded, so it's not out on YouTube because it wasn't a breakout session. It was what reInvent calls a chalk talk. But yeah, I think it really depends on the compute that you're running, right? Because if you want this code available, if you want these shared constructs available to you, then they somehow have to have context into your memory space and your runtime environment, whether that's your network or literally the virtual machine that's executing your code. And so it's a little bit different on if you're just running your code as a binary on an EC2 instance versus running your code inside of a container. And now when I say container, I actually mean a container like a Docker container. Or if you're running it, say, as a Lambda function, where now you're not only are you not in charge of the execution environment because that comes up for you, but you're also only running the scope of one function. So you don't have the shared memory space of this long running server like you do in a container or on EC2. And so we look at some of these different patterns where obviously in EC2, you can look at shared libraries, whether those shared libraries are dynamically loaded at runtime or whether they're statically compiled in. Regardless of what language stack you're using, I think every language stack, even JavaScript and Node, have ideas of sort of statically binding things together versus sort of dynamically loading them because they're on some sort of known class path to the virtual machine. So that's pretty straightforward, and there's nothing different about running that than you would on premises. And then when you start looking at containers, obviously you can also share things like that when you build your binary to deploy it onto the container. But often we find people taking advantage of a technology called a sidecar, which is basically a co-located other containers. So two containers running together in the same network space. So they basically have the same loopback network address, and they can talk to each other over localhost. And because that is a logical construct of the container, it's not a physical construct of the computer. That communication is super, super fast, and so the container has access to sort of the execution flow of what's going on inside of that container. So you can get all kinds of really neat things going on inside of containers, where you can essentially have background threads that are talking to a log collection system. So FluentD is super popular. FireLens is really popular. Sumo and some of our other partners also have sidecars that you can implement to gather up logging and metrics. But it's also a way to hide away some of these shared constructs.
Yeah. I think that's important to connect it back to this microservice story, right? Which is, you've got this sidecar in a container environment. It's sitting there sort of out of view, and yet you can put all this sort of logic and all this information into the sidecar, and it can just sit between you and other points of access. And so now, instead of just pulling in a library, you're sort of running, you're proxying almost that information, if you will, through the sidecar, right?
Well, the beauty part of that.
Yeah, go ahead, Toby.
Yeah, the beauty part is that you could write that, like if you're bringing in a library, right? You'd have to, if you were in Node, you'd have to write it in Node. If you were in Python, Python. But the sidecar you could write it in whatever, and it just runs kind of as its own little process.
Because it's a network communication. It's not an in-process communication. So say we take our metrics manager, for example, and we pull that out and we run the metrics manager in a sidecar. You may have a shim layer in your microservice, but it's actually opening up, port whatever on, 127.0.0.1, right on the loopback address. And it's making a call out on that network address, and it's getting a response back from it.
Right. So for me, I think the broader sort of theme here that you're saying, describing, is one where we'd say, yes, we have the classic sort of notion of just bring a library in and reuse a library and do a good job and be a good software developer there, and push all these multi-tenant concepts out into shared libraries. But then also in that same thought process, start asking yourself, which compute stack am I running in, and which tools does that compute stack give me to maybe even, I'll bring up one of the things that has come up before, and we see this from a lot of telemetry providers, is Lambda is trickier here, right? Because like you said, like what do I do there? I'll sometimes see people do wrapper functions, right? They'll do wrappers around their Lambda functions. And on the entry point, the wrapper intercept every single call. And then they're like pre-processing and post-processing something as a way to solve this, right?
Well, and we just announced, so we already talked about Lambda layers, right? So shared libraries and old school compute work the same way on EC2. Kind of sort of work the same way on containers, but now with sidecars, you have yet another pretty cool option with other features. We already talked about layers, which is a way to basically have shared libraries in Lambda and not have it directly pinned to your Lambda source package. But we just released a new thing called extensions with Lambda that actually do give you that sort of point cut, if you will, of the life cycle of a Lambda function, and give you as the customer access to those hooks. So I'm about, I got a request and I'm about to light up your execution environment. Okay, your execution environment's lit up. I'm about to invoke your function. I'm now invoking your function. your function is done running and I'm about to shut down the execution environment. And you now, as a consumer, you now have access to those points in the execution environment so that you can now, instead of doing wrapper functions where they cascade down to other lambdas and other lambdas, and obviously with all of the cost and latency that's associated with that and complexity of what your code looks like, now you can kind of do what we do with these sort of frameworks that intercept HTTP call and response, right? Where we wrap things like with the Express framework or the Spring framework, or Go Chi does this too, right? Where you have these filters that happen right before your method's going to be invoked on your RESTful service, and then after it's done executing.
Well, and even if you look at language-specific things like middleware, like Express and middleware, or if you look at aspects, which show up in different flavors and different languages. To me, these are more exotic ways to sort of insert yourself in a way that you're entirely outside the view of developers. And to me, if I can use one of those mechanisms and it really does what I want, I almost prefer that to the library model, only in that it's like, at that point, like isolation, it would be awesome to me to say I complied with isolation and had no idea I did.
Yeah, totally.
Because the code just sort of, the mechanism just took care of that for me. Cool.
Well, we've got 3 minutes left, Todd.
Yeah, and I think we sort of hit on the main themes here. I guess I would just want to maybe summarize a little bit here. And Toby, if you can drop a link out there in the chat to the workshop that is the workshop around layers. That layers example,
I did.
Don't be obsessed with the fact that it's layers, but it kind of does walk you through this and gives you a better sense of what it means to do some of these bits. And we do have some other content out there. Check out the dynamic policy generation. That's a really good place to start. And for me, think about building and force multiplying the development of your SaaS application by making the developers of those microservices have as little awareness of multi-tenancy as you can. To me, that's the real takeaway. And then obviously think about how multi-tenant affects which microservices you might actually be building in your environment. And I don't know, Toby or Michael, anything to add?
I just think, there's kind of no magic here. It's good software engineering, as Toby has been saying all morning. And don't be afraid to change your microservices, right? Don't be set in stone. You came up with a certain set of them. If they're not working, take the time to refactor and rethink or gather up more metrics to have more information to make better choices.
Yeah, and don't let perfect be the enemy of good here, right? Like, also, if you don't know what the microservices are, be willing to be a little coarse-grained to begin with, and let the microservices earn their way out. So, cool. Well, I really appreciate you joining us for this episode. Apologies for our little technical snafus along the way here, but hopefully we navigated that successfully. And I really appreciate you joining us for this episode, and look forward to seeing you for our next session. So thanks very much. Have a great day.
Thanks, everybody.
Thanks, everybody.